a bit more optimistic about AI than the general sentiment in this conference. So the whole premise is an assumption that there is a lot of value to be gained from agents coding and agents writing code. And it is about how to unlock that value and how to basically use AI and coding agents. Sorry. Can you hear me now? Yeah, okay. In a way that actually provides value. So yeah, that's about it. My name is Tal. I'm a software engineer and team lead. And just a little thing about me. So as my team grows and I have more and more people in my team that I work with, that I help, that I think about, I have less and less time to write code myself. I still do, but LLMs and AI are really making a huge difference there for me, because at any given time, even when I'm working on stuff that's not about writing or reviewing code, I still always have something cooking on the side, so I still have a chat open that I come back to after each meeting, after each whatever. So I always have a PR in the making on the side, and for me it is working great. And talking to people in the conference, and also even yesterday in a speaker dinner, honestly, I'm having a hard time bringing those two things together. So my experience with LLMs and coding agents, and the reports from other people in the conference, and the numbers that are quoted. So yeah, here I'm just going to assume that there is something to be gained from letting agents code for you. And so the starting point of this is that agents are really changing how we write software, how we do computing. It's a huge leap, and it changes a lot of things. You might point out the fact that this AI-generated picture shows a person who has one pair of headphones around her neck and another one on her head, but I think this is just this is maybe alludes to what comes next about. There is obviously a lot to be gained. I could never draw this little nice painting here, but obviously there is a lot of room for correction, improvement, verification. So up until a couple of years ago, it was basically only humans writing code for organizations, for projects, and now it's more mixed. So maybe in a show of hands, who here has a team that looks more like this? So for who in this room agents are writing a significant or some portion of the code? Okay, yeah, most people. Makes sense. But repeatedly, surveys are showing that almost everybody, or a huge majority of companies, organizations, people are using AI to generate code, but the numbers of trust in that output, or trust in AI and agents, are way lower. And I think also that's not surprising, right? It kind of makes sense. So we all have huge amounts of code being generated, or code can be generated so fast, and so much of it can be generated pretty cheaply, pretty easily. So the new bottleneck, unlike before, is not about writing code, about building things or making things. It's about their correctness and about validation of that output of what we make. Okay, we're back. Okay, so then you have agents writing code for you, and then there's a question of, okay, where do those agents run? They can run on your own laptop, right? So that's a basic use case. That's how I do it, right? I have Claude Code or whatever just on my laptop, and I use that. Once you try to scale it, if you're like in a huge corporation or whatever, you might want agents to become independent of developers and basically work in parallel to them. So maybe you're going to need to have them run in their own container, in their own environment, whatever. So the most basic case is you basically just give them access to the task at hand, give them access to push code, create a PR, whatever. But obviously, one thing that is missing here is a way for them to verify their output, right? Because kind of like a guaranteed way to generate garbage is to only give the agent the task at hand, let it generate code, basically generate a patch, and look at that patch, right? If the agent isn't running tests or any other kind of verification on whatever they generated, whatever it generated, it's guaranteed to have like really low quality in many cases. Whenever the complexity is non-trivial, it's not going to be good enough. So one thing that you can do, and like an understandable reflex, would be to basically run that agent in some sandbox where the agent can replicate the whole system, which might be fine for some kinds of programming. But if you're doing cloud native and you have a ton of microservices and different workloads and stuff like that, and different cloud services, and maybe you're using some APIs from like external APIs, it's going to become really wasteful to replicate the whole huge system for each agent, but it might still be necessary. Like it might still be necessary to give the agent access to all that information, to all those APIs, in order to actually let it verify its output in conditions that are realistic. So let's say you do have a sandbox where the agent runs. You still want it to verify its output against the when it's done generating code and testing and doing its like inner loop, at some point it's going to you're gonna want it to create a PR, right? So at some point that code is going to have to integrate, right? It's going to have to pass some tests on CI and basically go through your whole PR pipeline. And this is good, but you don't want it to have to go through that process more than once, right? It makes sense, exactly like with human developers, for the agent to be able to fastly iterate on code until it gets something with a high degree of so you can be like sure about your high degree of certainty about its output, and once that's done, you want it to push high quality code to create a PR, and then for the pipeline to run once and hopefully just succeed. So just like with simpler use cases of AI, once you add better context, you can significantly improve the results, right? So I think it's like kind of we can all probably imagine that if you take a lower quality model and you give it a browser MCP, so basically just access to Googling stuff, or whatever kind of web search, it's going to get way better results than without that, right? Because just kind of like a low quality model, if you ask it some basic question, and it doesn't have that web search MCP, it's going to hallucinate whatever, or it's going to like try its best using the weights it has. But if you give it like this web search MCP, it can just Google it and find the answers for you. So kind of the same logic applies to code verification, right? Once you just give an agent access to a way to verify its code, so actually run it in real conditions, it can significantly increase or improve the results you get from it. And what I'm proposing is using MirrorD for that. So MirrorD is an open source tool that we develop at Metalbear. And what it does is it lets you run services locally on your computer with access to a Kubernetes cluster. So basically whatever Kubernetes cluster you have access to. It can use your local kubeconfig, so you don't even have to configure any special access for it. It's just going to use the kubeconfig on the machine. And the idea is you can very easily and quickly run services. So let's say I'm working on some one little microservice out of my system, and let's say it's getting a request from other microservices via HTTP. So I can just run it with MirrorD, and it will run on my machine, but it will get access to I/O and resources from the cluster. So when other services create requests to that service, according to the configuration of the MirrorD configuration I use, I can get those requests to arrive at my local service, the service running on my local machine. Same thing for outgoing access. So like when my service, even though it's running on my computer, when it tries to access something that is only available inside that Kubernetes cluster, it will just succeed, thanks to MirrorD. So originally we developed MirrorD for humans, but as more and more of the coding work is being done by agents, also more and more of the MirrorD usage is coming from agents and not humans. So right now it's pretty mixed. But basically, the idea is to give agents the same good developer experience we give humans, and make sure that agents can verify the code that they're showing you. And yeah, MirrorD just works for that as well. So one possible scenario we've seen one of our bigger users doing on their system. So they have their staging cluster that they're sharing, and they already they rolled out MirrorD a while ago. So all of their devs are using MirrorD to develop new features to work connected to their staging cluster. And they're before that they were using personal environments. So like they were basically spinning up environments for each developer just in time, and that was costing them a lot. And then they switched to MirrorD, and basically they're just sharing one single staging cluster. And they wanted to see, well, okay, how can we now also scale up AI coding? So what they're doing, they're running agents in pods in their, like on their Kubernetes cluster, on their staging cluster. Those agents have MirrorD installed on their local pods. And they're using MirrorD to verify their output right from inside the cluster. And yeah, we have a blog post about it on our website. If you're interested, you can scan the QR. It will be available also at the end, so don't worry about it. And yeah, the whole idea is to shorten down the innermost dev loop, right? So the idea is not to deploy in order to test, because deploying code, so like containerizing, deploying, is both slow and intrusive. Because if I need to deploy my code in order to test it, then basically only I can do that. Because there cannot be more than one deployed version of the service I'm working on at the same time, right? Like only one service is going to get the request, etc. But with Mirror that's not true. So the whole idea here is not to go through the whole outer loop for in each iteration while working on the code, while still improving, while testing things, but rather having a much tighter innermost loop, and then only go through the whole pipeline, the whole change, when I'm done doing the more tighter loop. Okay, so one strategy that I'm proposing is basically just having giving your AI agent, your coding agent, a skill that tells it to use MirrorD when creating code for you. So basically, yeah, funny story. We're also developing an operator, so a Kubernetes operator, and that's for the like the commercial offering of MirrorD that's built on top of the open source part. And I write a lot of code for our Kubernetes operators, and of course, I use MirrorD in order to develop our operator. So I run our Kubernetes operator locally on my machine with MirrorD, and then it can handle stuff inside the cluster using MirrorD. And basically, when I do that, I just tell my whatever coding agent I use that day to verify its code using MirrorD. So basically, I usually tell it. So for example, if I'm working on a bug, I tell Codex or Claude. So first, reproduce the bug. Then explain it. So like find it in the code. Then then write code, so write the patch to fix it, and then run the same verification with MirrorD. So basically, it builds the fixed operator, runs it with MirrorD, runs the same reproduction, and verifies that this time the bug does not reproduce with the fixed version. So those are basically the steps I would go through when I was still writing all my code manually. But the idea is now I just let the agent do this whole thing. And one more elegant way to do it is using a skill. So if you're not familiar with the AI agent, or like Claude skills, there are at their most basic case, there are basically glorified prompts, right? You can save some instructions in an MD file and basically reuse them on multiple occasions. They can be a bit more than that because you can also include other artifacts and files and scripts in them. But basically for here, all we really need is this kind of a glorified prompt. So for that, I have a little demo. There's this little example app that my colleague Jake created for this. And it's this like little web app. Honestly, the architecture doesn't really matter. what's matter that we're going to add a new endpoint to an API, and we're going to do it using a coding agent that has this skill loaded. So let me just. Okay. So yeah, today I'm going to use Claude Code. And we can see that I'm invoking this special skill that we made for this demo. Also, my colleague Jake made for this demo. And then I'm asking it to add some new endpoint for the API, for the backend API. The details don't really matter. So basically, I'm just adding another API endpoint for the backend of this web service. The skill is in this case very verbose. So for the purpose of the demo, it has a lot of instructions. Obviously, you can adapt the skill to how different your day-to-day tasks are. So if you're basically the more similar, the more repeatable the tasks you do, the more information you can keep at the skill. But this one is very, very verbose. I have auto mode on, so that it will run a bit more smoothly, and we don't have to give it a lot of access to stuff. Okay, so we can see that the agent is instructed to first get some context, understand the thing, and understand the task. And it's going to write the patch. And of course, it is instructed to use mirrord in order to run the patch. And then it's going to run the tests against the basically the local service. So it's going to run E2E tests that actually access the deployed application. So we have a publicly exposed ingress, and it's going to send requests over there. But it's going to include a baggage in the HTTP headers that will tell mirrord to route those requests to my local service running instead of the remote one. So instead of the old version running in the cluster. Okay, so if we look a bit more at what exactly it's doing. Yeah, so it wrote the code, it wrote the E2E tests, and this is really the whole point here, is to close the loop, right? So we don't want AI agents to just generate text, because it's a huge waste of time to have your developers looking at just generated text, right? They should be looking at verified output. So we should demand or instruct our agents to actually run the code they wrote, verify it, and only then should a human even be bothered at looking at it. And the question is, how do you do that with cloud native code, right? Because running cloud native code is not trivial. And basically, mirrord wants to close that gap and make it possible both for humans and agents to run cloud native code very easily and quickly. Okay, so we see that it created a PR for us. That's part of the skill. So that's part of the instructions and the skill to also create a PR. And it's running the service under mirrord. And another thing we have in this demo skill is we asked it in the end, even though it's done verifying, we asked it to keep the mirrord session running so that the developer can also do another small round of manual verification. Basically, it keeps the service running locally, connected to the cluster, and then I can send curl requests to the cluster and get the the responses from my local running service. Yeah, so this is really nice. We can see that the agent here is, yeah, we can see that the agent here is like finding mistakes or bugs and basically solving it on its own. And this is honestly great because the whole point is to get the human out of the loop, get the agent to do the whole thing in a way that isn't intrusive, isn't dangerous for the team, and then basically only look at it once they're done. I think we can use this couple of minutes while it's still running to answer any questions, in case there are any so far. Are there any questions already? Yeah. Yeah, okay, so the question was about multiple developers, or I will expand this for this case for also multiple agents running at the same time against the same target, the same cluster. So yeah, that is a use case that Murady absolutely supports. So we can differentiate between two basic cases. So one of the cases, we have two agents or two developers using Murady at the same time, but against different targets. So let's say different workloads on the cluster. And that case is absolutely trivial. So you can adjust your Murady configuration. So Murady takes like a configuration file, and you can control the features in a very fine-grained way. So that's trivial. You can just look at the Murady configuration docs, and it will just work. And then there's a more involved case where you have multiple agents, multiple developers running against the same target at the same time. Whoops. Okay. Running against the same target at the same time. And that is something that is solved using our Kubernetes operator. But the Kubernetes operator is not part of the open source project, so I prefer not to talk about it too much today, but it's also on our website. So with the Kubernetes operator, that case is also trivially solved. So yeah. There was another question over there. Yeah. Yeah, so that's the nice thing. You don't have to Dockerize the code to run it, which I think is super important for a fast dev loop. Because, I mean, depending on what you're building, but Dockerizing can just take time. If you're going to have to Dockerize after each time you change like one line, I don't know, add a semicolon, whatever, you have to Dockerize again. It's just gonna slow you down or your agent. So Murady doesn't require you to Dockerize it. The way it works is the code run locally, so wherever you're working. So if it's a person, then on your laptop. If it's an agent, then on their pod where they're running, or wherever the thing is running, it's just gonna run there. And we have a dynamic library that gets injected into the process and runs, basically hijacks some of the operations and forwards them into the cluster, into the Kubernetes cluster. And we have an agent running in the cluster. In this case, it's not an AI agent. Yeah, the terminology kind of clashes there. But basically, there's like an agent pod in the cluster that forwards, basically, proxies all of those operations from inside the cluster. So that's how we prevent that need to Dockerize. Okay, I see I'm almost, actually pretty much out of time. So let's, okay, so I'm not going to get too much into it, but the demo is also available on GitHub. The TLDR is that the test passed, like the agent verified its own code against the real cluster using MirrorD. It's now leaving MirrorD running for me to also do some manual testing on my own if I want. And just to close this, so a couple of words before we finish. First of all, the whole idea is to increase to improve the quality of what you're getting from AI agents, not to even look at untested code, and like the same way you would never ask a colleague to just look at code you wrote because you feel it's right? So don't ask yourself or any of your colleagues to just look at generated text. Let agents close the whole loop, have a quick and complete dev loop. Here we have the link to the blog post of Monday.com that did the cool project with their agents running on their staging cluster. The other QR is for feedback about this talk. Please go ahead and share your feedback about this talk with me and with the conference. One small note, I got a couple of Metal Bear t-shirts with me. I have this one and I have a couple other ones, so if you're interested, please come forward and take your t-shirt. And I think I don't have any more time for questions, but you can just like ask me. I'll hang around here or outside, and you can come to me with any questions you might have. Okay, thanks.